Hi everyone, today we're going to be going over the basics of circular functions. Despite what people say, circular functions are not difficult, and it's one of the most rewarding kinds of things you can learn in maths, as it's quite a satisfying thing, as you'll see. Let's start. The key point to circular functions is what we know in maths as the unit circle. This is a circle that is on an x and y axis, and its radius is equal to 1 unit. That is, this circle has its center point at 0, 0, and at any point here you draw this radius, it is going to be equal to 1. So we can just write that in. R is equal to 1. Circular functions is essentially the connection between this unit circle and the trigonometric functions. As you remember, trigonometric functions, very simple. If you remember your SOHCAHTOA, it's just based off that. So this is just here for a reminder. So if we have a right angle triangle, of course, and this is theta. Theta is just another way of saying an angle. It's a Greek letter. The sine ratio of this angle is going to be the opposite divided by the hypotenuse. The tan ratio of this angle is going to be this side length divided by this side length, and the cos ratio of this angle is going to be equal to this side length divided by this side length. So as we can see, all these ratios cover the possible combinations here. Now, this relates to the unit circle because we can actually take a triangle out of the unit circle. So if you imagine the circle continues down this way, this is the x-axis, this is the y-axis here, and it kind of wraps around. Yeah, you get the picture. Here is our theta, and this is a right angle. As we know, the radius is equal to 1. On this triangle, you'll also notice that the radius is also equal to the hypotenuse. So we can say the hypotenuse is equal to 1 unit. And that means that if we take the sine ratio of this angle here, we will get the opposite, which is this side, of course. So the opposite the angle, as the namesake. We will get opposite divided by 1. Hypotenuse is equal to 1, so we just sub 1 right in here. So we can say sine of theta is equal to the opposite. If we look at cos, we can say it's the adjacent divided by 1, which just equals the adjacent. Now don't be fooled into thinking that these ratios of sine theta equaling opposite and cos theta equaling adjacent can be used anywhere in trigonometry. That is not true. They can only be used when we're dealing with the unit circle. So sine theta is equal to opposite, cos theta is equal to adjacent. What does this mean? Well, if we draw our triangle out again, if we know this is our r equals to 1 equals to h, if we know that this sine theta is equal to opposite, and this is our opposite here, can't we just write sine theta? And if the adjacent, this side here, adjacent to that angle is cos theta, we can just write cos theta in like that. So already we have a very basic picture of how circular functions work. We're imagining a circle, and the functions being used on it are sine and cos, and they are indeed equal to the adjacent and opposite. Now tan is a bit trickier. It's just a basic explanation of tan here. So we know tan is equal to opposite divided by adjacent, as we see here. This is theta here. Now, if we know sine of theta is equal to opposite, cos of theta is equal to adjacent, that means we can write tan of theta is equal to sine of theta divided by cos of theta. Now this is slightly harder to picture on a circle, but I will draw it out anyway. If imagine we draw a tangent to this circle. The tangent is a line that only touches the circle once at the point where x equals to 1. And we continue this tangent. I don't want to run into my working there. But and then we extend this radius like that. This distance is going to equal tan theta. Now this is slightly unimportant, but not as important as sine and cos. So only if at the moment if you understand sine and cos, that's fine. So let's get into a worked example. I'll put it up on the screen now as well. So our worked example is asking us. So we've got let me just have a look here. So we've got our axes and then our unit circle. And what does it look like? We've got an angle or a triangle that looks like this. It is asking us to label theta, sine of theta, cos of theta, and tan of theta. So theta is going to be the easiest one. That's just the angle that this radius makes with the x-axis. So we can go ahead, put theta right there. That's one mark. Now, sine of theta. If we draw, it's a bit cramped, but if we draw this in here, this opposite of this angle, of this triangle, we can say that here is sine of theta. Cos of theta. Cos of theta, as we know, equals adjacent. So we can just put cos of theta right here. And there is already theta, sine of theta, and cos of theta. Now if we remember, tan of theta is the tangent that this line and kind of the intercept between that and if you extrapolated the radius, when these meet, tan of theta is this distance here between tangent and the radius. So we can go ahead and label tan theta, and that is a very basic summary of circular functions, and I will be covering more in depth in coming videos. Thank you for watching.